Before we get started, I do have a question about last class.
Sure. Shoot.
Exactly where do you post the recordings from each session?
They're in the Google Drive on a file. I'll show you right here. If you go to our Google Drive in the main student folder, there are these meet session recordings, and they're the two older ones are from last term and then 2 terms ago, and then ours is this one, meet session recordings. And so here's the link to Monday's class.
Perfect. Thank you.
Of course. Any other questions?
I have a random question.
I'll try and give you a random answer.
Thank you. I watched the SAS workshop video.
Yeah. How was it? I hear good things about it usually.
Yeah, it was good. I'll be candid, I'm about halfway through because I keep repeating it. But I was under the impression that she told us that we had to have a library in order to be able to access our saved documents. I went through and I created a library, but now when I've gone back into SAS, I have no library, but my folder is still there and the work that I have generated is in it.
Yeah, I think that's probably what she meant. I mean,
okay, because I was like, man.
I mean, this folder, this data files folder that I created and this programs folder that I created these literally like 2 years ago when I first taught this course. And these files and programs have been there the entire time.
Okay.
So if you create if you just create a folder and put some crap in the folder, it's going to stay there.
Okay.
Yeah. What else? Any other questions before we officially begin?
Yes, I just wanted to say hello, Dr. McBride. This is Parag Siakabe.
Hello, Parag.
How are you doing, sir?
Fine, and yourself?
I'm good.
What can I help you with?
Oh, no, nothing in particular. I'm just
here. Okay. Just want to introduce yourself. All right. Well, I'm glad you made it.
Yeah, here for the ride.
Fantastic. Well, I think we're close enough to 4 that we can start. I mean, we've got 20 of you in here, so I imagine pretty much everybody who's going to show up is already here. So let's begin. Who wants to start us off with the first question?
I can start. This is Raven.
Sure, Raven. Go for it.
I was having issues with 3.4C.
It's 6 o'clock.
3.4C. Let's see. Okay. Oop, wrong week. That'd be week 2. Oh, yes, computing relative frequencies. Okay, so relative frequencies, as far as, you know, C is not really something that you can get easily from technology. So there's no, not that I'm aware of, there's nowhere in SAS where you can have it compute relative frequencies. In fact, I don't even think there's a way where it can compute frequencies because, you know, you have to put your numbers into bins. Basically, you have to put them in intervals and then kind of do all the counting yourself. So a lot of this stuff is best served. So a lot of 3.4 is best served in just Excel or Google Sheets or whatever kind of spreadsheet program you want to use is the best way to do that one. And then as far as relative frequencies are concerned, you're simply just going to take the frequency of each class interval and divide it by the total number, which in this case is 25 because we have 25 measurements. Now, can anybody prove me wrong? Has anybody figured out a way to do frequencies and relative frequencies with technology?
That was my one question. My one question was, how do I build frequency table in SAS? Because I couldn't figure it out.
I don't think it can do it. You know, I mean, SAS.
I just went to Excel, but I'm like, I don't know if that's right. But
yeah, I mean, even in Excel, it's not the easiest thing in the world to get it to do things. I find that, especially for these data sets that are so small, that it's easiest just to do it by hand. As far as, you know, counting frequencies and then doing relative frequencies. I mean, obviously relative frequencies, once once you have your initial kind of table set up, you can use Excel functions to populate cells really quickly and easily. But there's no like quick function that'll do the whole thing for you. You always have to kind of do the first cell and then drag and drop, so to speak. So let's see our week 2, 3, 4. Let's download that one. Save and open. And of course, I could have done all this in Google Sheets too. I mean, it's the same thing, but we'll go with Excel since that's what most employers are using these days. And actually, a lot of them are switching over to Google Sheets because it's pretty much the same thing and it's free. Oh, does yours look like this, or did I just do this and save it this way?
When you pull it up in SAS, you do get the relative that last column. I saw it, so
Oh,
to make a
It
histogram
does.
of that.
okay. So
It's
already in there for
It's
us.
already there. That's why I was wondering if.
okay, so I don't know if this was the way the file was originally. I'd have to go back to the class and see what happens. Did anybody download it from the class? I have a feeling that I did this a long time ago and just saved it for my students because I'm like, why should you guys waste your time recreating this? So when the frequencies are here, obviously the relative frequencies you can do by just dividing by 25, but I went ahead and, or somebody, either I did or the school did. So here's all your frequencies, here's all your relative frequencies. So it's pretty much created for you. I mean, at this point, you could just kind of format it and make it look pretty.
Okay, so you just want a histogram of column D.
Yes, exactly. So that's probably why it's there, so that you can get a histogram of that data. Yeah. So where is it?
Dr. McBride.
Yes, sir.
Go
ahead, Michael.
I thought we were supposed to do both a histogram of frequency and the relative frequency.
I believe you are. Let's see, divide the range. Yes, because here in part B, you construct a frequency histogram. So you do a histogram of just the frequencies. Then you compute the relative frequencies and then create a histogram of the relative frequencies. And it says right here, note that the frequency and relative frequencies for these data have the same shape. And they do, because that's what histograms are, right? A histogram, the height of the bar is representative in the first case, it's representative of your frequencies, how many each one has. Well, the relative frequencies, the relationships are still going to be the same, right? So for instance, if you had 5 items in category 1 and 10 items in category 2, then of course the bar in your histograms can be twice as big for 10 versus 5. But then if you do the relative for those, let's say that 5 becomes 20%, well then the 10 becomes 40%, and then again that second bar is going to be exactly twice as tall as the first one. So the shapes are going to be exactly the same because of just what histograms do is they show the relativity of each group to the other, right? Each size of the bar is relative to the size of the rest. So they're all comparatively speaking. So they're all pretty much already giving you percentages, even when they're giving you just frequencies. So that's why the shapes are exactly the same. And do we need to see how to do this in SAS, how to create histograms?
Yes.
Okay.
Yes.
So I double click on 3.4, hit the little running man to make sure that I've loaded it. I always like to click on output just to see what I've got. And 3.4 is fluoride. That seems wrong. Wasn't it 3.4 was the question? Or was it 3? Yeah.
3.4 is about fluoride.
Okay, so it is
It
about
is.
fluoride. So it looks like the one that I have loaded is the old version. It doesn't have all the extra data. So let me get that one loaded instead. So SAS Studio. Get rid of you. And the right one. There it is. Upload. All right, there it is.
And Dr. McBride, while you're loading that, this is my question all along about SAS is, and maybe I missed this, are we supposed to upload those data files into SAS ourselves?
Yes.
Okay.
That was something that you were supposed to do in week 1. And it's fine if you haven't already done it. I mean, you could technically load each one when you need to use it, but that's why in the Google Drive folder, I gave you this data set here in a zip file, and it says read me first. If you read this document, it talks about if you download this zip file and then uncompress it, right, decompress it so that all of your files get unzipped into one folder, then with all of your data files in one folder, when you go to SAS and go to upload and then go to that folder, you can actually highlight all of them and upload them all at once. With them in separate folders here where it's by week, you could still upload all of these all at once, but then you'd have to go and do the same thing for the next one and so on. So of course, after you download them, you can't upload them from the Google Drive. That doesn't work. They have to be living somewhere on your computer, and then it'll upload them that way.
Okay.
Yeah. Okay, so this one is the right one. It's got all the stuff we need. All right, okay, so now we go to tasks and utilities. Under tasks and then under graph, we see histograms. So we double click that. I always like to just click here. Selecting the table is always the fastest way for me. And then I know it's import 1. I have to choose my analysis variable, and we're running analysis on fluoride. And then the scale, right? If we do it by percent, let's see what we get. Right? Looks terrible. Well, it doesn't look that bad, but it's 5 bars. And I think the question said they wanted 6 or 7, right? Divide the range by 7. Some of us looked at it and rounding, right? So they want 7. So if we just go to appearance and bins and specify bins and make it 7 and run it, looks terrible because it sets it up, it sets the bins up the way it wants to do it rather than, doing it the way we want to do it. And if you go to the code, you can see that all it does here is change number of bins to 7. But I gave you guys some extra code here on the how-to guide that'll make it look a little bit better as far as getting it to look more like what we want, because in the homework it says it wants you to start your first bin at 705 by 0.705 and then have a bin width of this. And so if you just basically change that, create this code. So I'm just going to copy this code, Control C, go to SAS Studio, and if you hit edit, it's just going to create a whole new one with all of this stuff here. And I like to just start fresh. So I just delete everything and then plug it in here. Now I'm going to have to change where my data is, because when I saved this one, it put it into import 1 because of that, the one that I put in the first time and then didn't want anymore. So I changed that to import 1. We're working on the fluoride one, so all this should be good. I should be able to run it and it should look better. And it does. So that's my histogram for counts, right? For just frequencies. So you can see here that the y-axis is just showing me counts. If I go back to the code, and if I change scale to percent and run it, I now get it with percentages, and I don't even really need to use the other stuff, the relative frequency stuff. because this is exactly what relative frequency is. It's just the percentages. It's the same thing. So really all you have to do is change the scale to represent percent, and then that's the histogram for that part.
So that other small amount of code on relative frequency, that was just changing the bottom from 0.7 to show the actual interval, like the 0.705 and 755.
Yeah, basically what it
Is that
does
what
is it
that one was doing?
forces SAS to start your bins at a certain point and then make your bins a certain width. So what's going to happen is, you know, my bin is going to go from 0.705 to 0.755, right? Because if you go, this 5 is in the second place, so it's going to go 0.705 to 0.755, and it's going to count how many things are in that range, right? And then it reports that, or gives it to you in the form of the first bar, and then the second bar starts at 0.755 and goes up to 0.805, and so on and so on and so forth. So you end up getting these intervals, these exact intervals. I know this is kind of small, make it a little bigger. You end up getting these intervals by forcing SAS to start with this number and have a class width of that. If that makes sense. And then if we go back to count, I think if I remember this correctly. All right, so let's see. Here's an interesting thing. Look at my histogram, look at my numbers. What do you notice? So the frequencies we have in SAS versus the frequencies my histogram is reporting. Anybody notice anything?
Well, like the first one should be a 2.
Right.
And it's only like a 1.5.
It's a 1. Yeah.
1.
They don't match at all. In fact, if you look at them, they don't match at all. Cannot for the life of me figure out why, to be honest. It's somehow the way SAS is, I don't know. I honestly don't know what's going on here. I don't know why it's doing it this way. Because I'm pretty sure these numbers are correct. I guess I could go through and double check that these numbers are correct. Well, actually, I can see right now these numbers are wrong. This should be a 1. So that's the problem. These numbers are wrong. Because there's only one number here between 0.705 and 0.755. And then between 755 and 0.805.
Is column A sorted?
I don't think it is.
Yeah, because I think I came up with 2, 4.
Maybe that's why. So it probably is supposed to be 2. Oh yeah. So it is 2. Yep. Because you got 72 and 75. So yeah, so we're back to asking ourselves, why the hell are we getting different results? Why is SAS not getting these frequencies? Because it's pretty obvious.
I used that on your SAS Google sheet.
Mm-hmm.
There was something, 2 other lines of code that I put in that you had on there, right there to make it look really good. And but that was the relative frequency one. So what does that code below do? Just add a title and a height? I
think so. Yeah, it really just it fancies it up, I think, is what it does. Let's let's play with it. Let's see what it does. Because this defines the endpoints rather than just where the bins start. So let's see if maybe this code gives us a result with the correct numbers, right? So let's get another one. Let's see, we're in import 1. And and fluoride, so everything should be good. Let's run this one, see what this one looks like. All right, so 2, 4, 8, 4, 4, 2, and 1. This one looks correct. 2, 4, 8, 4, 4, 2, and 1. Okay. I have no earthly idea why the other one doesn't work.
Okay, because it
But-
didn't seem like there was much different in the code other than like
There
you said,
really
it changed
isn't.
the bottom labels, it changed the title, but it seemed like it was doing the same thing
Yeah, I mean,
as the other one.
all
the
of
numbers
all of
wouldn't
that
come.
stuff as far as the table or as far as, you know, the putting in this, which is putting a title above it, you know, and another title, all that stuff is just, you know, fun formatting. But you'll notice there is actually a huge difference between these two. The first one, the procedure is an SG plot. So it's just running the SG plot procedure. Whereas in the second one, it's running the univariate procedure, which is a completely different procedure, which is why when we look at the first one, the results we get is just a plot, because that's all we ran was the SG plot, which stands for something graphics plots or something like super graphics plots or something. I can't remember what the S stands for. But in this one, it's running a univariate procedure. And if you'll remember, there was a whole crap ton of extra stuff, right? It's running all sorts of analyses in addition to just giving us the graph, right? In fact, it gives us quartiles, right? It lists a bunch of quartiles. If you ever wanted the quartiles, that's kind of cool. All right, so there's all the quartiles that we could ever want. What else does it give us? Extreme observances. So it, you know, lowest and highest kind of things and how many times they showed up. All right, that's kind of helpful. What other stuff to give us? The univariate procedure. So it gives us the mean, the median, the mode, standard deviation, variance, range, interquartile range. All right, all sorts of fun stuff. I don't know why it's running this twice. Why is it running it? I don't know, I have to look deeper into what this is doing, but it seems like it's running the univariate procedure 3 times. First, it's running it on fluoride. Then it's running, then it's running it on the variable frequency. Oh, I know what it's doing. And then it's running it on the relative frequency. So it basically just ran the proc univariate on all 3 of the variables, which is strange because does it say it in the code? No. Huh. Oh, yes. Because we only told it to run the histogram on fluoride, but we just told it to run the proc univariate on the whole data. So it's running it on all of the data stuff. If we put in, I bet you if we put in var equals fluoride, and put that in there. Oops, put it there. I bet you if we run it now, we won't get all that extra stuff. Oh, no, what's it looking for? Statement is not valid. Okay. Well, the proc univariate maybe doesn't take a variable command, but that's why it's running it on all of them, because it looks like the univariate isn't being told which variable to run it on, but it is being told which variable to run the histogram on. But yeah, the big difference is just with this histogram function, you're able to tell it where the endpoints are and how to go up, you know, how big the steps are. You could do, I'm pretty sure you could do the vertical axis label and all that kind of stuff with the other program as well, and it would be a problem. But that's definitely a nicer histogram. And then this one's frequency, right? So we could go back to this code, and what would we need to change to go from frequency to percent? What part of the code do you think we would change?
V scale?
Yeah, exactly. Instead of v scale equaling count, if you just delete this out, it should, oops, if I put an equal sign here, it'll give you your options and you go, oh, I just want percent. And then run it with percent. And what the heck? Why is it still saying count or frequency?
Did you all have to change your
think
v-axis label to %?
Oh, yeah, I bet you're right. Let's
As well as, yeah.
just get rid of this. Let's see what happens if we get rid of this. Or let's see what happens if we put equals. What are our options? It doesn't tell us. Okay, let's just get rid of that and see what it does if we just put it as %.
But you'll have to change the label as well.
Oh yeah, it's still frequency.
No, if we go back to v-axis label, yes.
Right. Yeah. Well, that's why it's coming up as frequency. But
I
then,
think I went back to the histogram and changed it there.
oh, and these numbers
then
are
put the-
percentages, aren't they? Those are percentages.
Yes, that's correct.
Yeah. So let's put the v-axis back in there and see what we get with this. Remind myself, oh, what did I screw up? Oh, the v-scale. Percent. All right. Yeah. So we definitely you need to futz around with the axis, the v-axis, and definitely change this to %, and then you can get it looking with the %.
So change the frequency that is in the parentheses to
Right. You would have changed this because this is just a label, right? I mean, we could change this to right, and then run it, and there it is. So you can make it say anything. So you could just change this to %. And then it's going to say
It's
percentages, even though it's not really percentages, because then you got to change the scale as well. So
So maybe like 40 or 30.
I
think the highest one was
guess,
like 32%.
let's see, if you put an equals in there, usually, let's get rid of the other stuff. So oftentimes if you just put an equals there, it'll tell you what your options are, but it doesn't look like it's giving me that. So let's just try 10% to 50%. See what that does. And then what was the other one? It
Our
was,
lowest one was 4%.
was it?
4 to 32.
All right, so let's just do
0.04 to 0.32.
Let's do one to 40. Well, let's just do 0. We should start at 0. 0%. We should always start at 0. What are we talking about? Does anybody remember what the last one was? What was the code? V scale. That's right. V scale equals %. Put our semicolon in there. All right, fingers crossed. Let's see what this does. Ah, son of a gun. Expecting one of the following: a numeric constant, a date time constant. Okay, so it probably doesn't like the % symbols. So let's just do this. Let's try that. There you go. I'm sure there's a way to also make it so that the percentages, they don't show every 2. You know, you could say 0 to 40, probably like by 5 or something like that.
Does that other last little line in your SAS document do that?
What do you mean?
In your SAS how-to guide?
By 5. Look at that.
Okay, there
Woo! I'm not a moron. See, I don't know. To me, this is fun. I like playing around with this because I'm not an expert at this. This is just, you know, we're just futzing around and seeing what happens. You know, you can't break it. So have fun, play around with it. I mean, this, like I said, this code came from a student a couple terms ago that she was just gung-ho on playing around and doing some cool stuff. And so I included it in here because I thought, yeah, this is really cool. So You know, if you had done the other histogram, the easy one, the one that we did at the very beginning, I still would have given you full credit on the homework. You know, I'm not going to be a hard nose when it comes to this stuff. I just want you guys to play around with technology and be able to get a decent histogram out of it, because most likely for your dissertations, you're going to have to reproduce a decent histogram for some of your data. So you better learn how to do it somewhere, whether it's SAS or Excel or Vassar or StatCrunch or Desmos or, you know, any online graphing tools that you can find, whatever it is. Just make sure that you can make these things look pretty for your dissertation. And then, of course, when it comes time for your dissertation, yes, you will need to, gosh darn it, I'm just going to get rid of that tab. So I stopped clicking on it. You're going to have to figure out how to do labels, because, you know, you can't put an unlabeled chart into your dissertation. That's just Bush League. Kofi. I see your hand.
Yeah. Yes, please. I was wondering if you could take the 3.54 again, because when I try to use the code in the how to stuff, it doesn't seem to work. It gives me some strange lines. So
Absolutely. Absolutely. Are
even
we
if
good?
I check the bandwidth and all that, it doesn't give me
Yeah.
the right histogram.
3.54, you said? 54?
Yeah.
Okay. Are we good with 3.4, everybody? Any remaining questions on 3.4?
No.
We're all good? Okay. Then let's check out 3.54. All right. 3.54. Load this one. Check my output. So it's just damages. And then the question wants us to draw a histogram of the data using 6 or 7 categories. Right. Okay. So we can go back to histogram, go back to data, delete this thing, pick up import 2, pick up our damages. Under appearance, God, I just read it, and that's how bad my memory is. Didn't it say 7? 6 or 7, yeah. Okay, so let's try 6 and see what it does. Ooh, that's horrible. Yeah, and same thing if you do 7. And that's the problem with the histogram function, is it's just too basic. And you're going to get things like this, where you have these little tiny things here and then these big ones here. And sure, go ahead. I mean, again, if you put this in your homework, I'm giving you full credit. You followed the instructions. You made it. It's got 6 or 7, although it's crappy 6 or 7. You know, you could do better with some of the programs. So let's look at the code and let's try, like you said, we'll try the code that I gave you guys. So let's go to the first code, this one. And, you know, I'm going to put it here so we compare and contrast. Okay, so we know that we need to change this to import 2. We know that we need to change this to damages. And then we need, this is something that we discovered last time, is that we need to change our bin start to appropriate numbers. So if we go to our data, we can see that our numbers, right, are big numbers. And what's the smallest one? It looks like 361.
361 is your smallest.
Okay, so let me go change that. So let's start at 350. And oh, what happened?
You have your inserts on. I did the same thing.
Okay,
On your
thank
keyboard.
you. And then bin width. And then what was our largest one?
Your largest one is 2,197. So I think I started at, I made
want to
my
go to
bin
22.
width at 300.
Okay, yeah, because I was gonna say we need to get to 2,200. So let's just try 300. Okay, and then we can get rid of this now that we see. I left this here just to help me know that I had to do import 2. Okay, so now let's run it and see what we get. All right, error, expecting a thing. Oh, probably when I deleted. All right, let me go back to the code. Where did I screw up? Oh, it's after that. Oh, okay. It was after the, not here. It's expecting it here. Pay more attention to the error message, dummy. There we go. Yeah, so that's a much better histogram. And it looks like we have a class with 0, right? Because our count here is 1. So even if there was only 1, it would be up here. So something like this, it's much easier to see what's going on. The scale is better. You know, the largest number is 6, whereas before I think we had like the largest number was like 30 or something. It was way off. So the data has been kind of binned better. It's been put into classes better. And that's really, you know, what the coding allows us to do, is it allows us to control for where the bins start and how wide they are, and to get things looking better that way. So, you know, that was how many? 1, 2, 3, 4, 5, 6, 7, right? So if we tried like 400, 1, 2, 3, 4, 5, 6. So there's one that's got 6, and we no longer have a 0, 1. So that one would be fine too, right? Because the homework said 6 or 7. So, you know, either one.
Dr. Brown,
Yes.
I still have an issue because when I use the menu, because when I put it in the code, it wasn't working. So I tried to use the menu to do it. But when I change the bin size to 9, I get something similar to this. I don't know if you can try that and see if it works. Oh.
Oh yeah.
Yep. This one.
Sure. Yeah, that's pretty similar. But you can, that's fine. You know, if you want to do that, that's fine too. Again, I'm not going to be a big stickler. I mean, technically, this is not what the homework's asking for because it wants 6 or 7, but,
yeah, but
7 doesn't look great.
Yeah, and 8 gives you something different.
8's even worse.
But
Yeah.
9 works fine. I don't know why.
Yeah, 9's not bad. 9's pretty good.
It's only that there's 2 and with yours, with the code, it gives you 1 at that end.
Yeah, that's cool. I mean, that's fine. You know, you're playing around with it. Obviously, I still think the program is a lot better, but if you can't get the program to work, then do what you got to do. Use that one. Any other? Sorry.
There's another question on 3.55. It says, describe the method by which the mean of the combined data can be obtained. I don't know whether we're looking for a formula or we're going to use SAS to calculate that.
No, I'm just asking you guys to describe how you would do it. Right, so describe a mathematical method by which you could get the mean for all the combined data sets from the 5 individual means. So if somebody, so for instance, if somebody gave you the results from part A, right? So let's run part A, and I'll show you what I'm talking about. So we go to test and utilities, summary statistics. We want import 2. Our analysis damages. Oh, wait. Classification variable. Well, this is the wrong data. 3.55. That's the problem. I need 3.55. Yeah, there we go. Okay, so sorry, back to summary stats, change this to this one. The analysis is expenditures, and then of course the classification is the number of members. And then for options, we want the mean. I don't want anything else. Calculate the mean, so just wants the mean, okay. So let's get rid of all the extra junk and just run that. Okay, so here are my 5 groups. Here are my 5 means. So let's say you were, you know, thumbing through a research article and you came through this, you came across this table of results. From just this table of results, could you calculate the mean of the entire set of data? And the answer is yes, very easily. I want you to describe that mathematical process that would allow you to do that. Does anybody know what it is?
Standard deviation.
No. Good
Oh.
guess. No, we're finding the mean.
Put weights
You add
on
them
the
and you
means.
find the average.
All right, hold on, Kofi. Somebody else was speaking. What was that?
Weight the means. Do a weighted mean.
Exactly. You do a weighted mean. So you just take this mean, multiply it by its number of observations, and do that for all of them. So the mean times this number, mean times this number, mean times this number, and add all those together, and then divide by the sum of all the observations, i.e. the total number of things. And you're basically doing a weighted mean. Yep, that's it. Very good. Okay, so that's 5-5. Who else got a question? I see Michael, you're, nope, you're done. Okay, Danielle, you still off mute? You have a question?
I apologize. I didn't realize I was off mute.
No, you're fine. That's just what I use to designate. Kofi, you still got your hand up. Are you good?
I'm good. I'll get it done.
Okay, thank you. All right. So who's next? Any other questions?
All those and then add.
Sorry, what was that, Montrese?
You said you multiply all the mean times the number, and then what you do at the end?
You add all those together. So you take each number of observations, multiply it by its mean. So you get a bunch of products, right? This times this gives you something. This times this gives you something. Do all those. Then you add all of those resulting products together, get a big grand total, take that big grand total and divide by the total number of observations. That's what's called a weighted mean.
All right.
Cecily?
Yes. And if I dreamt this up, you please tell me.
Sure.
But on question 3.10, and we were using SAS to construct the relative frequency histograms for the 3 different years.
Yes.
Did you show us on Monday, and maybe I dreamt it, how to do all 3 of them at one time?
Yes. But I was
Okay.
showing you how to do all 3 stem and leaf plots, not all 3 histograms. But
Okay.
you could do something very similar with your coding with histograms, right? So this programming here, where it shows all 3 variables for all 3 years, if you basically copied that piece into the code for making a histogram and put it down here, you know, histogram, I wonder if it would. It probably wouldn't. I don't know. You'd probably have to do histogram and then put in the first variable and then and then maybe copy
Will
that.
we have to, would it be similar to the other code where the histogram was created using the proc univariate? I'll play with it. I have some time, but I guess in my mind, I played with it for a while. I gave up and just did the histograms individually, but I just was wondering. Okay.
Here's what I would do. What do they want? They want frequency or relative frequency for this one?
Relative frequency.
Relative frequency. Okay, so we need percentages. All right. So so here I just loaded the data for 310 and I just went to the standard histogram function, and you can see that when I tell it to do it for 1985, it puts this in here, right? and percentage is the default, so it doesn't put anything in here for the scale because that's just what the default is. If I run this, of course, it's going to give me just the one for 1985. If I want all of them at the same time, I bet you I can go edit and basically just copy this and paste it and paste it, and then change these to the other 2 years, which is 96 and 2002. So 1996 and then 2002. And let's give this a shot, see what it does. Oh, it stacks them. Okay. So then what you'd probably have to do is it looks like you'd probably have to run this whole thing just 3 times.
You got to run it separately.
Yeah, I think so, because I think even if you had the y-axis grid, that's not going to change anything. Let's see, what was our...
Well, that's okay. I thought I had seen it done Monday, and I couldn't recall. And yesterday, our little group met. I won't say little group because there's some mighty women. Thank God for them. And they and we tried it, and we didn't have much success. So that's
yeah.
why.
I'm looking at all of these different codes, and it's always histogram with one variable. And you can see that it's quite different than coding where you're just putting in a variable.
Okay.
And so when you do that, you can put in more than one variable. But when you have a function like histogram that you can only run, it looks to me that SAS only lets you run that once. So in order to get all 3 results, you would have to just copy the code, right? You would basically just have to have this code generate it 3 times, Control C, and just at the end of it, do Control V, and if we change these, I wonder if we'll see all 3 results or if we'll just get the last one. Let's see.
It's all 3. That's what I did.
Oh, look at that. Nice.
Okay.
So there you go. So you get all 3 as your results. Fantastic. So yeah, so it looks like that's the way to get it, is you just have to copy it and run all of them.
Okay. Well, thank you.
Good question. Okay, what else?
This is on a side note, Dr. McBride.
Yes,
I
sir.
wanted to say sorry for Monday night and your Buckeyes.
Thank you. Yes, the wife is still moping around the house, so it's tough.
Can I still get an A on my?
No, I don't want to hear it. I don't want to hear it
All
ever.
right. Okay.
Parag?
Oh, yes, sir. You caught me with that one. No, I was going to ask for the, do you prefer snippets, or would you, do you mind if they're just like copied from the Excel? Because I noticed that the Excel brings its functionality over into the Word document.
So if you're going to copy graphs into the Word document, I don't care if it's a snippet or like in Excel where it's kind of a live living thing. That's fine, just as long as the graph is there and I can see it. So, and I've said this before, and I don't think you were with us, but if you're going to take a snippet, for instance, of these, please take a snippet of each one individually and paste it, rather than trying to get, the whole thing, or, take the whole screen and give me all, because then these things get so small once you put it in the Word document that I can't read any of the details. So I can't see if things are correct, because I have to be sitting here checking, okay, are these frequency numbers the same? Does it say percent? All these little details that you can't read when the graph is super tiny.
All right. Thank you.
Of course. Oh, and since you're asking about things like that, for those of you that are submitting your documents to, the Canvas, or we're Canvas. Basically, when you're submitting it to the assignment link, please don't use, so in the Word document, please do not use the highlighter tool to highlight your answers, because when it converts to what's called speed grader in Canvas, which is kind of this, it's a nice tool where it gives you a preview of the document, gives you a full screen preview of the document, and it gives you some tools where I can annotate on it. So I can go in there and I can cross things off, and I can highlight things, and I can basically tell you what's right and what's wrong. And then if you had used the highlighter tool on the Word document, when it does that preview thing, it doesn't come through as a highlighter. It comes through as a yellow redactor. So basically, I can't see anything under. It's just big yellow bars over everything. So if you're trying to highlight your answers like I asked you to, and I appreciate you doing that effort, please don't use the highlighter. Instead, put things in bold, put things in a different color, make them italics, put a space, so here's the question, space, 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 or whatever. Here's the answer in bold, space, space, space. Here's the next question. Those types of things make it really easy for me to find your answers. But unfortunately, the highlighter tool does not work. Now, since we're talking about the speed grader, I had one student who was having trouble seeing my feedback in speed grader. So has anybody gone in and looked at my feedback on like the first submission and can explain to the rest of the class how that is done? Because I can't replicate that because I'm not a student, so I don't know how it looks from your side.
I have. This is Kim. All you want to do is go into Canvas to the assignment itself.
Okay.
And in there, when you pull up that submission, when you do the submission, so pull up the assignment.
Let me see if I can go to student view and see what it looks like from student view. Huh.
Dr.
May not have a
McBride?
test one.
Yes.
Right there. There you go.
There. Thank you.
Yeah, there you go.
It used to say student view. They really
Yeah,
like to.
I have to look on mine. That's not good. So then, yeah, pull up that assignment. When you do the submission, so you have to submit an assignment.
Yep.
Okay, so submit an assignment.
I'm just going to submit something. Okay.
So now where it says submission details,
Yes.
click on that.
If you click on that, okay.
Right. And then where it says view feedback in the right corner there, no, go back down into where your submission line is at. So at the left of the gray box where it says you may not see all comments, it says view feedback.
Oh, view feedback. Thank you.
That's where you do it.
And then you get the preview of the document. Oh, fantastic. And then this will show all my stuff.
Yes.
Thank you so much. That is very helpful. Thank you, Kim.
No
So
problem.
hopefully if the person's not in the class right now, they'll watch this and then be able to see my feedback. And maybe there were more people that were asking about that, because that is not an easily figured out procedure. Wow. Okay. Thank you. That's very helpful. That'll help me explain it to people in the future as well. Okay. Back to the homework questions. Do we have any more homework questions? Yep.
I was just going to make one comment. Like if this student, like myself, for example, and we submitted it early,
yes,
then you didn't give us any feedback. We don't submit it. We emailed it to you.
Right.
So we didn't submit it through this. So I don't
Right.
know that we would be able to see the feedback.
You wouldn't. Yeah. So if you emailed it to me early and I looked at it and it was good to go and I told you, you're good, you've got your 100 points, you don't need to submit it, then yeah, obviously you won't be able to see anything because you didn't submit anything. And the feedback you would have gotten was from the Word document with track changes if there was any feedback. Oh, and Cecily's saying that you can also download the feedback document. I'm wondering have you tried that? Does the document that you download actually show all my feedback on it then?
I haven't done it for this class. I've done it for a previous class, and it did show the professor's feedback.
Oh,
yes,
cool.
and I do the same thing on all my submissions, especially the writing assignments.
Yeah.
You can download it and save it so you can look at it while you're up making changes.
Okay, so if I strike things out, it shows a strikeout. If I highlight it, it shows up as highlighted and all that kind of stuff?
Yes.
Oh,
You'll have the
nice.
colors, everything.
Oh, fantastic.
Dr.
Yes,
McBride, I was
Parag.
going to tell you, I did go and do exactly what you just did, and I can actually see the feedback in the information and everything that you put in there.
Perfect. Awesome. I emailed you, but it shows missing. But yeah, exactly, Dennis. If you emailed it to me and I told you no, you don't have to submit it, then it's going to show missing, which it shows as for me as well. When I go in to put the grades, it says this student has not submitted, and I just put the grade. I put in 100 anyways because you've already technically submitted it by emailing it to me. So yeah, that for any of you guys that are doing the free preview, as I like to say, when you send it to me for me to look over, and if you end up sending me something that is good to go and you don't need to redo it, and I tell you as such in my reply email, that I just immediately go over and already put 100 in the grade book just so I don't have to worry about it later, and it'll always say missing because you technically didn't submit it in their system, you just submitted it to me via email. Okay, what else? Oops, get rid of that. Any other homework questions?
And that's just for this week's homework questions? Or?
If you're working ahead, Jacqueline, it sounds like nobody else has any other questions, so we could definitely look at something ahead.
Well, I was going to ask one question. It's very small.
Go ahead. Yeah, go ahead, Montrese.
It's for 3 points. My apologies. It's at 3.54, and it was just asking about the biases of the histogram. I just wasn't sure about how you wanted me to answer that question.
So you mean part D where it says what does the relationship between the mean and the median indicate about the shape of the graph or shape of the data?
B. Letter B.
Oh, on the base of the histogram, what would you guess the mean to be? That one?
Mm-hmm.
So the idea of that is it's literally just a guess. So you would just say, okay, well, according to the shape, I would, it looks like the mean would be somewhere around blah, 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 because, it's either skewed to the right, it's skewed to the left, or it's, so just describe the shape of the histogram. Tell me if it's, relatively bell curved or if it's skewed or that kind of thing. And then, if it looks like it has an outlier or those kind of things, and then tell me what you would guess the mean to be. And then of course you're going to calculate it the next part.
Thank you.
Yeah.
All right.
Cool. Okay. Any others from this week's homework? All right. Jacqueline, you're up. Which one you got for us?
3.30. So I was able to do the relative, I had a question on relative frequency histogram, but you answered that today. Perfect. With this week's assignment, because we just have to manually make the table.
Yeah.
So I think that's not a problem. And the mean, and C is calculate the S, that's the standard deviation. So I'm kind of stuck with that next sentence.
So where it shows this Y plus and minus S and Y bar.
Know what
Okay, so let's pretend.
Okay.
I'll use some numbers and then you'll see it and it'll make total sense.
Okay.
So let's pretend that if you run the data, your average, which I don't know why they're calling Y bar. It really bothers me that they don't call it X bar, but okay. Anyways, the average, let's say your average tree was 5. And let's say your standard deviation was 1.5. Well, then this interval is just going to be 5 plus 1.5, which of course is 6.5, and then 5 minus 1.5, which of course is 3.5. So that first interval is going to be 3.5 comma 6.5. And what that represents is if we had a normal curve, right, and we have an average of 5. If we go out 1 standard deviation in both directions, so we go up to 6.5 and down to 3.5, the empirical rule tells us that this should be roughly 68% of our data. Now, of course, we have no idea if our set of data comes from a normally distributed population or not. So we don't know if, our distribution would be a normal curve, but when we run the data, right, we can actually calculate this interval, and then we can go through our data and we can count up how many of them are between 3.5 and 6.5. Obviously, since they're whole numbers, we're just looking for 4s, 5s, and 6s, right? So I'd count up all the 4s, 5s, and 6s, and I would, okay, so that's, 13 of them, and then it's 13 out of, however many total, and that gives me a percentage, and then that's where I can compare the percentage I get from my data to the empirical rule and say if it's close or not. And then of course for the next one where it says y plus or minus 2, well, now that's just going to be 5 plus 3 and 5 minus 3, because we just multiply 1.5 times 2, and that gives us an interval of 2, 8. And technically, we would not include 2 and 8 because it's technically a not equals, but I would take either answer, So do I count 2s, 3s, 4, 5, 6, 7s, and 8s, or do I only count 3s, 4s, 5, 6, and 7? So you should probably really only count 3s, 4s, 5, 6, and 7s. This doesn't matter because your standard deviation is not going to be a nice, pretty, whole number. So these are always going to be decimals. So you're always going to be fine because, if this was 2.2, you know that you're going to then have to start at 3s, right? Because it has to be bigger than 2.2. And if this is 8.1, then you can go up to and include 8s. But anyhow, you would do the same thing. You would count up how many trees are in this interval and then figure out what that is as a percentage. We know that according to, let me change colors actually, because I'm just that good. I'll make this blue. And then, nope, why are you not blue? Come on. Blue, blue, blue. There you go. So we make this blue. Oh, that looks just fantastic. Blue and blue. And this, we know, is roughly 95% of our data from the empirical rule, meaning the whole thing, all 4 intervals, right? So the mean plus or minus 2 standard deviations gives us 95% of our data, i.e. down to 2 and up to 8. And you would count yours and figure out what that was as a percentage, and then talk about, is it close, is it far apart, and then do the same thing with 3, right? So we take this times 3, which is 4.5. So we get 5 minus 4.5. So now we're down to 0.5. And then 5 plus 4.5, we're up to 9.5. So of course now we're looking for things bigger than a half. So we start with 1 and smaller than 9. So we'd count all the trees between 1 and 9, and we would do the same thing, figure out what that percentage is, and last but not least, we'll do a good old ugly mustardy color. I'll put that one in here. And those 3, the empirical rule is, oh, now of course it's completely frozen on me, 99.7. And so you would do the work and see what yours is, 99.7%, and that's from 1.5, sorry, 0.5 to 9.5, and that's all 3 of these, right? Is supposed to be basically 99.7, and you would, figure out what your percentages are according to your data and according to your intervals, and then compare it. And that's what you're doing with C. Does that clear all that up?
Yeah, it does. I was still, I didn't understand like what the Y was. I didn't know what that meant.
Yeah, the Y bar
yeah.
is just their
Y
way
bar.
of talking about the sample mean, right? So they say calculate the sample
Okay.
mean Y bar. I don't know why
Oh,
they call
yeah.
it Y bar.
I
It should
didn't,
be
I
X
don't know why I
bar.
didn't.
Yeah,
Yeah, I read that, but I didn't put that together with that. Okay.
It's really stupid.
Okay, no, that helps.
Yep.
Okay.
Cool. Anything else from anybody?
Do we have class next Monday?
Yes. Is next Monday a holiday?
Yes, Martin Luther King.
Oh, yeah, it is. Yeah, with online classes, I don't normally follow holidays, but these are voluntary anyway. So if you're out celebrating, you can't make it, just watch the video.
All right, thank you.
Yep. Kofi?
with next week's assignment, is it together with the mini project, or I'm not sure how many things you're supposed to submit next week?
Yeah, I think next week you have both the homework assignment and the mini project, if I remember correctly.
That's correct.
Yeah. Yeah, so you got both the homework and the mini project are due next week, which is why it kind of tells you to start working on the mini project this week in the instructions. So yes, next week, mini project and homework. So you might want to get working on both of those ASAP.
Can you open up mini project report?
Is it not open?
Oh, no, I just haven't. I can open it later. I haven't even looked at it yet. I was working on homework 3, but I didn't even
Yeah,
realize.
so you've got a set of data that you
Okay.
download and load into SAS, and then it's just got some questions for you to add, to do. So you
Similar to
generate
what
some
we've done
stuff,
on
generate some
homework.
stuff. Yeah.
Okay.
So let's talk about this really quick, because there's a couple things that people really screw up in this in the mini project that really pisses me off. I shouldn't say pisses me off. It really disappoints me that people get this wrong, because it's such an easy thing. And it's so here's the data for the mini project. All right, so let's. Okay, so here are all of my data pieces. There, we can see them all now on one page. So you've got a variable called subject with all these D numbers. And basically this is just a locator variable. This is a trash variable, complete waste of space. Then you've got treatment, gender, family history, blood pressure, age, blood pressure before the experiment, and blood pressure after the experiment. Okay, there are some questions in the mini project where you are supposed to use quantitative data, and there are other questions where you're supposed to use qualitative data. Now, which of these variables are qualitative? Kofi, your hand's up. I don't know if that means you want to answer the question or. So who wants to venture a guess? Give me one qualitative variable, just one.
Gender.
Gender, very good. Okay. What's another qualitative?
Family history.
Family history. Awesome. There's a third one. Who can get me the third one?
Age.
No. What was it?
Subject.
Treatment. I heard it way off in the distance.
Oh,
Seth, I think
sorry.
it was that Seth?
My microphone is probably bad.
No, it just sounded like you were 7 miles away. Perfect. Yes, those are the 3 qualitative variables. Treatment, even though they are numbers, they are just the numbers 1 and 0, which represents they got the drug or they got the placebo for a 0, right? So these 3 are qualitative variables: treatment, gender, and family history. So any questions that ask you to do things with qualitative variables, you will use those 3. So for instance, they say generate at least 2 different cross tabulations using categorical variables only. Well, categorical variables is what they call qualitative variables. So you will make cross tabulations choosing 2 of these at a time, right? So you'd make one between treatment and gender, between treatment and family history, or between gender and family history, right? There's only 3, ways you can, pick 2 out of 3 things. So those would be your 3 tables. If you wanted to make all 3, they said just generate at least 2. When they say generate frequency tables for 3 categorical variables, well, I just told you what those are. So you're generating those for these 3 variables, not subject, damn it. Subject is a crap variable. It's these 3. And then when they go on and ask you to, do 5 number summaries, mean and standard deviation for 3 quantitative variables, well, our 3 quantitative variables are age, BP before, and BP after. Okay, so these are, things from week 1 where we talked about the different types of data, but qualitative, or what they call in this, they call them categorical variables, are things that just describe a character, right? They're not a quantity, they're not a measurable thing. And then of course, quantitative, quantity, right? Quantitative variables are the things that are quantities, either discrete or continuous. So let's talk about that. With these three variables, are any of them discrete? And if so, which one? Or ones?
Age?
Yes. Age, the way it's reported, is definitely discrete because everybody reports their age as in counting the number of years they are old. But in reality, age is considered a continuous variable because we don't count our age, we measure our age, right? Because age can be measured in smaller and smaller units of measure, right? So we can measure age by years, we can measure it by months, by weeks, by days, by hours, right? Those are all different units of measure. You can't see me doing air quotes around units of measure. So whenever you have different units of measure, you know that that variable is a measurement. And when something is measured, it is a continuous variable. So technically, age is a continuous variable, but in reality, it's usually treated as a discrete one because people report their age discretely, right? Nobody says, I'm 49 years, 6 months, 2 weeks, 3 days, and 14 hours old, right? I mean, if you met somebody like that, you would just go, all right, douchebag, I'll be over the other side of the bar. You have fun. So age ends up being discrete, even though it really is continuous. And then, of course, we all understand that the other two are absolutely continuous because you measure someone's BP, right? You put a little instrument on them and you measure their blood pressure, right? So anything that is measured is continuous. So these two variables are definitely continuous. This one technically is continuous, but it's been reported discretely. Does that matter for the project? Not at all, because nowhere in here does it ask about continuous versus discrete, but I just wanted to remind you all of it because it's one of those things that students really struggle with wrapping their head around. What the hell is the difference between a discrete and a continuous variable? And I hope I have driven that home at this point. Okay, so I've at least given you the starting bits so that you won't choose the wrong variables. So you all should be able to run out there now and start working on the mini project as well. As far as what I expect, just follow the instructions. It's pretty straightforward, right? You're just going to generate these things and throw them into a report, and you're going to submit a report. How professional does that report have to be? Not that, right? It says annotate the output as a report to include any bibliographic citation, any interesting information you found, and your interpretation of each summary, right? So you're summarizing every single one of these. You're giving a brief summary of what you've done, what you've gotten, and what it means. So think of this as you were given this set of data by your boss who knows very little to nothing about statistics and basically says, hey, go run all this crap and let me know what you find. And that's what your report is going to be. It doesn't have to be, 17 pages long. We're talking about this thing. If you took out all the graphs and you just had just the words, right? If you had just your interpretation, it would probably be 1 page, 2 at the most, because you're just doing a quick little interpretation. Well, we ran this and we got this result, and you can see from the graph that the data is skewed right, which means that the mean is bigger than the median, which means we have an outlier on the upper side. And, that makes sense because blah, 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 blah. Or, whatever the case may be. It's just a quick little interpretation of the results with complete sentences, right? When it says follow proper APA style and citation, it just means complete sentences. You don't have to cite things. If you want to cite the textbook, fine. But I mean, you're not going to be quoting people. You're not going to be citing other sources, so if you want to practice, putting together, citations and a bibliography or a reference page or whatever that, fine, go for it. But I'm not going to be looking that deeply at your stuff. I just want a couple sentences, right? 1 to 2, 3 at the most sentences about your results for each of these, 8 or whatever things there are. And you can either describe them after each one. Here's my result, here's my description, here's my blah, blah, blah. Here's my result, here's my blah, blah, blah. Or you can just go, here's all the results, and then here's my, discussing all of them together at the end. Either way is fine. Just make sure that, you know, all of these things are there and they're labeled, and it's easy for me to tick them off. I can go, yep, there's their frequency tables. Yep, there's at least 2 cross tabulations. Yep, there's a Pareto chart, right? I just want to be able to tick off that you've done all these things and that you've talked about them, and full credits coming your way. It's that easy, okay? Questions?
I believe that the only question I have is, if we do submit our mini project, do you want that done before the Friday of next week if we do, or is that the deadline?
The project is due Sunday midnight of next week, just like the same thing as the homework. If you want my feedback on anything, it's always due midnight Thursday of each week. At the latest, it better be in my inbox by the time I wake up Friday morning, and I'm on Pacific time. So I can tell you that I usually get up somewhere between 6 and 9 a.m. depending on how jaunty I feel each morning. So you can roll the dice, man, but if it's not in my inbox when I first come down, I ain't looking at it. So try and get it to me.
So we can get it in earlier this week if needed.
You can get it to me as early as you want, just as long as it's before the Thursday of next week. Yeah.
Okay.
Yeah. Yeah, some people have already sent me their mini project. I mean, some people are working way far ahead, so you can always work ahead and submit stuff early. All right, anything else?
Thanks for pulling it up.
Yeah, no problem. Nothing else? We're all good? All right. Congratulations, Cecily. The rest of you, enjoy the rest of your night.
Can I give y'all just a quick funny thing?
Sure.
I did not, I've always been a University of Alabama fan, but if you know SEC football, I got my master's degree at Auburn, so everybody talks about me here.
Yeah, yeah, talk about a rivalry.
Traitor.
Traitor.
Yeah, War Eagle.
Bye.
All right, everybody have a good night.
Everybody, good night. See you next week.
Good night.
Thank you. Good night.